Hello, everyone, and welcome to this lesson on different types of large language models. So, as we all know, this certification program focuses on fine-tuning large language models for language generation, which is typically the experience that you would get when you are interacting with ChatGPT or Claude, where you type some prompt and the LLM is going to start responding by generating language. So, this type of experience was very popular recently that you might think that the word LLM or language models specifically refers to this kind of experience, language generation, when in reality there are different types of language models. And this was, or the base for these models was actually set in 2017 when Google released a paper called Attention is All You Need. And they introduced the transformer architecture in this paper. So we will be going through the transformer architecture. We'll explain briefly what it is and how does it relate to the LLMs that we see today, like ChatGPT or Claude. And yeah, we will discover three different types of language models. So namely, they are encoder-decoder models. There are encoder models, encoder-only, and there are decoder-only models. So yeah, let's take a look at these three types and try to understand what the difference is. So as I mentioned, the foundation for LLMs was set in 2017 when this paper came out. And I'll leave a link to the paper in the lesson itself. I encourage you to read that paper. It's very interesting, and it is really the starting point for all the LLMs architectures that are out there today. So they introduced what's called the transformer architecture, which is what you're seeing here on the screen. Don't feel overwhelmed because this is how I exactly felt when I was looking at this diagram for the first time. We will not be going into details on how each of the internal blocks function, like the attention or the feed forward. But this is going to be rather a general idea on how the architecture works, and then how LLMs actually build on top of this architecture. So as you can see, there are two main parts for this architecture. The one on the left is called the encoder, which is this part here, and the other one is called a decoder. So when Google introduced this architecture in the beginning, the main task was machine translation. So even the task that's described in the paper is given a sentence in English, maybe try to translate it to French or German. So this was the original task for the transformer. And the main task for the encoder was to understand the sentence in the source language. So if I'm trying to generate a translation from English to German, the encoder's task would be to fully understand what the English sentence means, try to understand the semantic meaning, try to understand how each word in this sentence relate to other words. And then after the encoder finished processing this sentence, it would pass it to the decoder. And the task of the decoder would be try to generate the translation. So decoder is only responsible for generating the German sentence or the French sentence. So this architecture is called an encoder-decoder architecture, basically because it has these two parts. And this architecture is excellent whenever you are trying to do complex tasks that requires you to understand the input and analyze it before you start generating the output. Keep in mind that this architecture, it doesn't have to be only used for language generation or translation, I mean. It can be used to solve most of the problems that require you to understand the input and generate something meaningful out of it. So let's take a look at one of the models that follows this architecture, the encoder-decoder architecture. So here I'm using the transformers library. I'm importing three models. For now, let's take a look at T5. T5 is an architecture that is an encoder-decoder. It was developed by Google, and again, the original task was language translation. So if we run this and we look at how the model looks like, you would see it has an encoder, So all of this is under the encoder part. You can see it has the attention layer, the feed-forward network, which are these parts. So this is the attention, this is feed-forward. So you can see it is implementing what we have here in this image. And if you scroll down, yeah, you'll see that it also has a decoder. And yeah, this is basically an encoder-decoder model that can be used to solve the kinds of problems that we discussed. The second type of models that we have is called encoder-only models. These are models that makes use of the encoder part of the transformer. They completely throw away the decoder. And these models are mostly used in tasks that don't require language generation. For example, something like sentiment analysis, when you are given a sentence and your task is to classify whether this sentence is positive or negative. So for a task like this, you don't need to generate any language. Instead, you want to focus on the input that you have, understand it very well, and then output a probability for each class, probability for positive, negative, and neutral. So for tasks like this that don't require you to generate new language, encoder-only models are very good at this task. So the encoder-only model that we have here, the example is BERT. So again, BERT is very popular, introduced by Google. So if you look at the BERT architecture, you'll see that it has the embedding layer, which is the one that we have here. It has an encoder that has, again, the attention and the feed forward, which is, again, what we have here. And you can see it doesn't have a decoder. So it's only an encoder followed by a pooling layer, which is the last layer in BERT. Basically, this gives you a vector representation of your input. So you input a sentence, at the end you get a vector of this length representing the input that you gave to the model. The last type of models we'll be covering here is called decoder-only models. We're talking about models that make use of the part on the right. They completely ignore the part on the left. So when we're talking about decoder-only models, we're talking about almost all of the LLMs that are very, very popular today. We're talking about GPT, Llama, Mistral, so all of the very famous large language models that you might have tried recently are actually decoder-only models. And these types of models are actually generating language. So there has to be a decoder because, as we agreed, the decoder part is the part responsible for generating or speaking or generating new tokens. So it has to be there. For the encoder, you might include it or you might not, based on the task. So if it is language generation, there has to be a decoder. An encoder is optional, so you can do language generation with an encoder-decoder model, or you can do it with a decoder-only model. But research shows that decoder-only are very good, and yeah, most of the time they outperform encoder-decoder models, and decoder-only are the type of architectures that almost all the companies today are using in creating their own LLMs. So as we said, an example of decoder-only models is GPT, which is the architecture behind OpenAI's ChatGPT. So if you look at the model, you can see it doesn't have two parts. It's just a single part. They don't call it the decoder here. They call it H. But basically, this is the decoder of this model. Again, it has the attention layer and the feed forward, which is called MLP here. Again, which are these two parts that we showed in all the different models. So one last thing to note, most of these models can be tweaked to perform different tasks. For example, BERT is not only for sequence classification, meaning you give it a sentence and you try to classify whether it's positive, neutral, or negative. So this is one of the things that BERT can do. But actually, BERT can also do token classification, meaning you're, for example, let's say you're trying to detect the names in the text. So given a text that contains names of people, you want to mark these names and yeah, try to classify whether a token is a name or not. So this is a different task. Both of these tasks can be performed by BERT, and that depends on the head or the last layer that BERT has. So to make this more concrete, let's look at the vanilla BERT model. So this is how BERT, the original BERT model, looks like. Let's take it here and put it on the right. And let's take a look at BERT with a classification head, meaning this is how BERT would look like if you want to use it for classification. So let's put that on the left and let's compare them. So you can see this part is the same, the encoder is going to be the same, and then you have this BERT pooler as the last thing, and on the left, which is the one with a classifier head, you have this part. This is the only extra part. This is the only difference between the one on the left and the one on the right. So this one has a classification layer, which takes in the vector representation of your sentence, and it gives you two probabilities. So this assumes that you're trying to do binary classification, where you classify if a sentence is positive or negative. If you want to change that, you can easily do it by, I think you can pass here something like number of labels, and let's set that to 3. And yeah, if you look here, now you only changed the last layer. So all of the model weights that are in the encoder are pre-trained. This is the only introduced layer here. You can see now it has 3 classes, so you're doing multi-class classification. And yeah, this is the only layer that needs to be trained because the weights in this layer are random. So yeah, this shows you that different models can be tweaked to produce or to solve different problems. So the last thing we have here is we'll show an example on how to run these different models. So here we're using T5 for conditional generation, meaning we'll be using it like a regular LLM, like ChatGPT, and yeah, basically we'll give it an input and we'll see how it responds. So here we're saying translate English to German. We're giving it a sentence, and you can see it prints the translation in German. So yeah, this is an encoder-decoder model. A use case for BERT, which is an encoder-only. As we said, we can use it for classification. So here I'm importing a fine-tuned model called DistilBERT. DistilBERT is a smaller variation of BERT. So it's the same architecture, but a smaller model, fine-tuned on some data set. So yeah, here you can see we're giving it sentences, and we want to classify whether a sentence is positive or negative. So this movie was amazing. You can see it's positive. Here's the probability that the model is giving you. Terrible service, negative. Product works as expected. This is again positive. So this is a use case, the most common use case for encoder-only models. And finally, decoder-only, which the certification program is going to be focusing on, because these are the architectures that are used by most LLMs out there. So we're using GPT-2. We are asking it to generate language. We are putting a limit of 100 tokens, and we just give it the beginning of the paragraph, and you can see it starts generating the language, and it will stop either when it hits an end of sequence token or it hits the limit of 100 tokens. So in this case, it hits the 100 tokens and it stops generating. That's it for this video. We explored different types of LLMs. This certification program is going to be focusing on decoder-only models because they are the most widely used in LLMs today. I think it was just useful to you to know that there are different architectures that are used in different things. And yeah, well, basically when you see that someone calls BERT a language model, you should know that it's not technically wrong. BERT is a language model, but it's an encoder-only model that cannot be used to generate language. So yeah, I think this distinction was useful. And yeah, I hope you found that insightful, and I'll see you in the next video.